Welcome to a new Voltlog. Today we'll be talking about eMMC memory chips and how you can use them in your next project and whether or not they provide any advantage over a more traditional SD card. So historically, MMC memory was first and then SD memory cards were developed based on MMC specification but added new features. Both technologies are based on some form of flash memory and they both contain a controller in the same package with the memory. Electrically, it's the same interface for both in most cases. However, software-wise, SD cards add some features which are not supported in the MMC standard. And while standard MMC comes in a card form similar to how SD memory cards are, eMMC stands for Embedded MMC and it comes in a BGA package. The purpose of eMMC is to be used as non-volatile storage in embedded devices, and almost all mobile phones and tablets used this form of flash for main storage up to 2016, when UFS started to become more popular. eMMC flash chips are available at every important distributor. They come in whatever size you need up to very large storage units, but I had some of these 4GB units left over from a recent project, so I figured I'd do something with these chips. I've always wanted to try and connect these to an SD card interface and see how it goes, do some measurements of read and write speeds, and evaluate overall if they are really compatible. So I thought about creating this adapter PCB that would hold the BGA eMMC chip and would provide the same shape and size as required by a microSD card. I started with the schematic in KiCad, which is pretty simple. It just has the two footprints, the BGA and the microSD card footprint, which I had to create, and their respective signals connected together. I've also added a couple of bypass caps just for good measure. And in terms of layout, this is a 50 MHz interface, so it's not super critical. It can certainly be done on a two-layer board with a solid ground on the bottom layer, and for such a short distance you don't really need to do length matching, but I did it anyway because I wanted to play with this feature in KiCad. And the nice thing about this BGA package is that there are a lot of unused pins which are not connected. And so in order to escape the inner connections, you can go straight through the unconnected pads without issues. Because otherwise it would be a real pain to escape these signals. You would need to either go to a very small track width or you would need a micro vias. All said and done, I ordered the PCBs at PCBWay.com, which are the sponsor of this video, and because this PCB was so small, measuring just 31 by 20 millimeters, I figured it would be a good idea to panelize these to get more units from a single order. But instead of doing the panel myself like I always do, this time I ticked the option where PCBWay does the panel. And they did so very nicely. Here are the panels where they were of course packed and protected very nicely inside the box, as they always are, but I opened the package earlier to take a look. And the PCBs look very nice. I opted for this Enig gold plating with the standard green solder mask, and that's usually the standard when working with BGA chips. I'm talking about the Enig finish because the pads are so small on this BGA footprint that you want the flattest and most perfect contact in there for each ball. I did not order a stencil for this board because for my technique of soldering these BGA chips, I do not use any solder paste, and if you'd like me to do a separate video describing my technique, there is also a clever way of checking if your BGA is soldered correctly or not, and I can show you all of that in a separate video. Just let me know in the comments below that you would like to see that. So here is one of these units assembled with the eMMC chip, and if there is one thing that I would adjust in Rev B of this design is the size of the micro SD card part of the PCB. So I designed this to match exactly the size of a micro SD card, and we can check that by placing one on top of this. You can see I pretty much designed it to match the size of the micro SD card. But I forgot about microSD cards, which are recessed inside the enclosure of many devices, and I can give you a few examples of those. My higher microscope camera does that. The Creality 3D printers do that as well. So you basically have to push the microSD card inside the case with your fingernail to get it inserted. Well, because I have these edges in here, you won't be able to do that with this adapter PCB unless you file away a couple of millimeters from those edges, which I did for this assembled unit. I used the metal file to do that. So in RevB, I would probably make this section longer for insertion into these recessed slots. So right now I can just insert this into an SD card reader and it will pop up as a 4 GB SD card on Windows. At least I haven't tested what happens on other operating systems, but I don't expect any differences. Now I wanted to know if there are any performance advantages over a regular SD card, so I took a selection of micro SD cards from my arsenal and I ran them all through some tests. I used Crystal Dismark version 8 for this, which was the latest available on their website, and I'm not sure if this is the right tool for the job or not. I would appreciate your feedback in the comments if there is a better tool out there for testing such memory devices. And of course it would have to be free as well, but I have used Crystal Dismark in the past for benchmarking hard drives, SSD drives, and it worked really well. And what I noticed during my test was that there wasn't any significant difference between testing with 16 megabytes chunks versus 512 megabytes. So I stuck with 16 megabytes and ran a 5-pass test for each of these microSD cards with the default benchmark. And here are the results. As you would expect, the slightly newer and more expensive SanDisk Ultra A1 performed a little better than the cheaper older microSD cards, and the eMMC drive had the lowest write speed performance out of the bunch for the sequential 1 meg test, but performed similar to the other microSD cards on read operations and got the best results for random 4K operations, which would translate to a bunch of random tiny operations but done at the same time. So unless you're doing those kinds of operations, I wouldn't say the eMMC has any advantage in this game, but also I wouldn't say that there are very big discrepancies between these two. They're pretty much the same stuff, and as with SD cards, if you buy a slightly newer one, a more expensive one in a better class, it would perform better. I expect the same thing with eMMC chips. If you buy a more modern chip, it will have slightly better performance. In terms of reliability, manufacturers do not like to publish endurance numbers for SD cards or eMMC memory chips. They don't tell us the expected write-erase number of cycles from these chips, but a typical MLC type flash memory endurance is around 3000 program erase cycles, as mentioned by other manufacturers, but I've also seen numbers as high as 10K mentioned in some resources. And typically eMMC chips are based on MLC type flash memory. There are rule of thumb formulas that you can use to calculate and estimate the endurance of such a memory chip, but to give you some context, a rough estimate for a 4 GB chip, you should expect at least 3000 times 4 GB divided by 2, and that's 6 terabytes of data written to the memory chip before some cells start to degrade. But there should be internal provision for some spare memory locations, and the controller should switch to those as soon as it detects a bad block. So in real life, the user should be getting more endurance, and this all happens in the background. So other than allowing you to test these eMMC flash memory chips, such a PCB adapter can also be useful for data recovery purposes. Let's imagine you have a broken USB memory stick or some other brick device which stores data inside an eMMC chip. As long as the eMMC chip is undamaged, you can solder it to an adapter like this and read it like an SD card and recover the data. Cheap, large capacity eMMC chips are also sometimes available on eBay and AliExpress as surplus stock, and if you wanted to build like a 64 gigabytes storage unit, you could try and search for those on, like I said, eBay and AliExpress. This design is open source. You'll find a GitHub link below so you can download it. You can order your own PCBs, or if you'd like to order one ready-made. I will also be offering these PCBs on my Tindy store, which will be linked on screen right now. On my Tindy store, you will find some of the past and current projects I make offered in limited quantities, so check it out. That was all for today. Thank you for watching. Let me know in the comments if you have ever tried connecting an eMMC chip to an SD card interface, or if you have other thoughts on this project. Don't forget, you can support the channel on Patreon with as little as $1 per month and smash that like button. I will see you soon.